Good morning. My name is Kalpesh Rajput and I am the student of Alma Beta. This is my third capstone project and the first classification project name is Credit Card Default Prediction Project. Now moving forward to the technical notebook that you wait a bit on sharing my screen. This is our technical notebook. First thing giving is the introduction of our project. Default credit cards are an important issue that brings negative consequences to the both sides. Like default credit, not we are using credit card. The credit card affect both sides, like banks and the customer both sides affect the credit card. Example, bank and the customer. If a customer does not pay his obligations, bank lose money. If any customer not pays the credit card bill, then bank face the charges of the debt. And the second, the customer will lose credibility in the future. The second loss is the from the customer side. Customer lose the credibility, and if the customer default the payment of credit card bills, his civil score get decreased in future payments. Collection calls start to be made, and in last resort, the case may go into court. In order to avoid all that trouble, effective methods that are able to predict the default of credit cards are needed. Therefore, default credit cards prediction is an important, challenging, and useful task that should be addressed. In the recent years, the credit card issuers in Taiwan faced the cash and credit card debt crisis. The delinquency is expected to peak in third quarter of 2006. In order to increase market share, credit card issuing banks in Taiwan over issue cash and credit cards to unqualified applicants. At the same time, most cardholders, irrespective of their repayment ability, overuse credit card for consumption and accumulated heavy credit and cash card debt. The crisis was a blow to consumer finance confidence, and it is a big challenge for both banks and the cardholders. In this project, we are see the introduction of our project. Now, next step is the problem set. What are the problems that we are facing in our project? The this project is aimed at the predicting the case of customers' default payments in Taiwan from the perspective of risk management. The result of this predict accuracy of the estimated probability of default will be more valuable than the binary result of classification. Credible or not credible clients, we can use the KS chart to evaluate which customer will default on their credit card payments. Basically, we are seeing the in this project, basically the customer is making default in his credit card payment or not. Now moving to the data description. What are data given by the in this project? Data description, attribute information. This research employ a binary variable default payment. Default payment. This is the column of default payment. Yes means S denoted by 1 and no denoted by 0 as the response variable. This study reviewed the illustrate and used the following 23 variable as exploratory variables. These are the variables. First is X1, the amount of given credit $20. It includes both individual consumer and the credit and his her family supplementary credit card. X2 is a sender. Sender means one is equal to we denote one is as a male and two as a female. Third is education. We denote one as a graduate school, second as a university, and third as a high school, and fourth as others like no education and etc. X4 is the marital status. A person is married or single. One denotes the married and two denotes the single and third denotes the other. X5 is equal to age. In X6, we denote X6 to X11. We are giving the history of the past payment. We track the past monthly payment record from April to September in 2005. As follow X6 denotes the repayment status in September 2005. X7 denotes the repayment status in August 2005. X11 denotes the repayment status in April 2005. The measurement scale of a repayment status is -1 is equal denoted by the pay duty. 1 is equal to payment delay for the 1 month, 2 payment delay for the 2 months, as on, and the 8 is payment delay for the 8 months, and 9 is the 9 denote the payment delay for 9 months and above. After that, X12 to X17 denotes amount of all bill statement as in the NT dollar. X12 denotes the all of bill statement in September 2005. X13 denotes the all of bill statement in August 2005. Adds on, and the X17 denotes the all amount of bill statement in 2005. And last is the X18 to 23. It denotes amount of previous payment, and X18 denotes amount paid in September 2005. And last column is X19, the amount paid in 2005. X23 is our last column, and it denotes the amount paid in 2005 in April. Now moving to the steps involved. What are the steps we are involved in this capstone project? First step we do in the EDA on our capstone project is the full form will be the exploratory data analysis. In this analysis, after loading the data set, we compare our target variable, that is default payment, next month with other independent variable. This process, just a second guys. If I'm giving record, now it's better. After loading the data set, we compare our target variable, that is default payment next month, with other independent variable. This process helps us figure out various aspects and relationship among the dependent and the independent variable. It is gave us a better idea of which features behave in which manner compared to the dependent variable. These steps are involved in our EDA project. EDA. Now moving to the null values treatment. How we treat the null values in our project. Our data set didn't have the null values to be treated. Outlier treatment isolation. Forest algorithm isolation. Forest is the tree-based algorithm that is very effective for both outliers and novelty detection in a high dimension data. Encoding for categorical columns, we use one hot encoder converting to dummy variables to produce binary integers of 0 and 1 to import our categorical features become categorical features that are in string format cannot be understood by the machine learning model and need to be converted to the numerical format. Now next step we're doing standardization of our features. We make a standardization on our features. Our main motive through this step was to scale our data into a uniform format that would allow us to utilize the data in a better way while performing fitting and applying different algorithms to it. The basic goal was to enforce a level of consistency of uniformity to certain practices or operation within the selected environment. Fitting different model for a modeling, we tried various classification algorithms. First is we use the logistic regression, we use the support vector machine, decision tree. Now we move into the random forest classification, then we use the XGBoost classification, then we use the CADBoost classification. After last we use light treatment classification. Uh, uh, Using all these algorithms, we find the accuracy of training and testing data set, finding CRUC score and all the matrices. Now next step we're doing is the turning to hyperparameters for the better recall. Turning the hyperparameters of respective algorithm is necessary for getting better accuracy and to avoid overfitting in case of tree-based model like random forest classification and the XGBoost classifier. After doing hyperparameter, we giving the feature in explainability, how our feature is important for that. We have applied SHA shape on the XGBoost and the CADBoost model to determine the features that are most important while predicting an instance and also build a feature importance graph to find out which features were important and which were redundant in the model. Now we move to the conclusion. From the project, we can conclude that the default rate is higher for males, increase as the education increase and also increase as the age of the person increase. Example, the client is over 60 years higher than the mid age and young people. In all of these models, our default revolves in the range of 76 to 84%, with the best fit model as the random forest. Now our technical documents is sent. Now we will look into our collab notebook, how we are doing our project. I will share my Google Colab link. This is my project. The project title, thinking whether customer will default on user or credit card. We giving the project title, the customer is getting making default on his payment or not. This is project summary. You already see in the technical notebook. This is my GitHub notebook. You can see my whole project on this GitHub link. This is problem description, data diffusion. We already see in technical documents. This is the data description. This is the performance metrics. These are the points to be noted. And let's begin with our data. First thing, we have to import all the libraries that are necessary. We have to import. We import in all the libraries that we using further. First, data loading. We mount our drive, then after we give our dataset name as a DF, then we see data overview, df.head, df.tail. These are the columns. What is information about dataset? There is no null value in our datasets. Then we count the row and columns, how many columns are there and how many rows are there, checking the description of the data. This is all the data description. We make the info to find what our data set looks like. Df dot column, df dot hello, all the columns. Now data cleaning. We are see the there is no null value in our data set, no NA value in our data sets. We can also plot for the null values. We are not looking any kind of uh, line in this just because we don't have any null values in our projects. Now we find out these all things by the above coding and data processing. We give our all the data as the name and we make the dot head looking outlast. We are looking outlast in our isolation forest. Then we use next scalar, then after we use isolation forest. For that, after we do AD and feature engineering, this is most important thing in our project. We give the defaulter column as a name is defaulter or not. Zero means zero and ones. We plot this here. Zero means non defaulter and one means a defaulter. Then we use the bivariate analysis. First, we have categorical column like sex, education, and the marriage. Then we define name as a df underscore cat, and we put all the category column in df dot cat, and we find the shape of that categorical column. Then we find the counts the all the categorical features by using this code. Now these all things are we are done in our projects. Now moving forward to the observations like what we get observing above coding. Coding function to cohort age of the group. We making the uh, group of age like 21 to 30 or age are included in this particular term for better understanding. Then like in 21 to 30 there is lower defaulters are there. Now we go observation from this and now we are plotting all we are plot for the is payment defaulter or not. When we giving us a month for the describe how many months, describe the month payments and we are using what lot. After the result, means we are using Airflow to scale our data set. Now this is the correlation like ID and the multivariate outliers with the most uh, correlated to each other. Handling class imbalance. We are handling our class imbalance by the node function like symmetric, geometry, geometry or sampling technique. Using this technique to handling the class imbalance. After that, we use the way before giving the training and testing data set. Then we create the function. This is the most important thing we are using in our data set. Like we create a function to predict model and that we will extend y plane and extend y base parameters on the base course. After creating this function, we are directly predict all the things in just giving one single line of code after importing any of the uh, machine learning model. Like we creating the functions for the getting the feature input and then we first use the logistic regression in our data set. Logistic regression. Input logician, we give a log model name as a logician, and we use the function to predict all the training and testing data set. Now run an evaluate, we give our model name, then scale x, train, y, x, train, which test, y, train, y test. Now we find out the accuracy of our data set is the accuracy percent. Is overall good, not bad, but it is good. The persistence score is the 0.95, the default is the 0.76, the F1 score is 0.85, the AUC is the 0.86. Except the default score or all the scores are good enough. This is a confusion matrix that we find out from the logistic equation. This is the classification tool for and this is the testing accuracy. The accuracy is 0.86, the precision is the 0.95, the default is the 0.77, the F1 score is 0.85, and the OHC is 0.86. Now, when the configure package for the test data set and the classification for the data set. After using the we implemented research for the hyperparameter tuning, we do all that and giving and after giving hyperparameter, we use the research series and giving the all the parameters parameter dictionary to all data set and the giving parameters 12 and next value is 1000 and giving the model. We are finding the accuracy is not much yet high from the using the hyperparameter. It is the same as the using guys using the logistic regression. After that, we plot the future importance, which feature is the most important. We are seeing the age group of 21 to 30 is the most important features for the logistic regression. Now we use the decision tree, then we find the accuracy of 82% and the test accuracy is also 82%. We also find the future importance for the decision tree, and for the decision tree, the future importance is the sex of male. Like sex, male, how males are, male and female category is the important for the decision tree. After we decision tree, we use a random forest classifier. We give the name as RFC model and run and evaluate out our RFC model. We find out this is the our overfitting. We overfit for the training data set, but our accuracy for the virtual data set is the good enough. After using hyperparameter tuning, we deal with the overfitting problem, and we find the accuracy of 94%, which is fair good enough for our model. And the testing accuracy is fair enough with the 0.87%. And also we use the feature importance for that and the payment in September is the most important feature for the random forest. 9th SVM, like support vector machine. We also give run and evaluate about our support vector machine to find out the training accuracy and testing accuracy. We find out the 0.87 is the training accuracy and the 0.87 also for the testing accuracy, which is good enough for there. We do not stop until we get accuracy above 95.95%. Like we doing hyperparameter for the SVM and we find out accuracy get increased by the point 29 and the testing accuracy by 8%. Testing accuracy does not change after using hyperparameter tool. Then we use the XGBoost for XGBoost classifier and we find out the accuracy is 0.92, which is good enough. After doing hyperparameter tuning, then accuracy is increased and we find out the 99% accuracy, which is excellent for our model. And the text accuracy is fair enough for the 0.6, but our text training accuracy is 0.99%, which is good enough. And also we use the feature importance for the XGBoost and we find out the sex mail is the most important feature for our dataset. Then we use the CAD boost for finding the training and testing accuracy. After giving our silly model, we put it into our function that we are creating and we find out just a second, this we find out the 0.90% accuracy and the testing accuracy is also 0.8%, which is pretty not bad, but this after using hyperparameter we find out the testing accuracy is 94, which is excellent. After using hyperparameter, we in our all the model we are seeing after using hyperparameter tuning, the accuracy of the training and testing data set get increased, which is most important. Period 194 and 56. The future important that the education of university is the most important feature for the care policy. Now, after that, light GBM. This is our last model that we are using in our project. After using light GBM, you find out that it's about 8%. After using hyperparameter, you find out accuracy get increased by the 0.89%. Now the future importance for the LGB, LGC, light GBM for the future important light GBM is the ID. You don't know how the light GBM takes more important to the ID. By our point of view, the ID is not necessarily using that information. Then using ROCOC of all the models and find the ROCOC curve and we get conclusion that the best accuracy is obtained for the logistic regression and the stochastic regression. In general, all modules have comparable accuracy. Nevertheless, all the classes are indirect, the proportion of the non-deposit is large. And we also see the conclusion in our technical documents. And last year, before the execute classifier and decision tree classifier, and also we one point we are including the random forest classifier get the best accuracy in our data set. Thank you, everyone.